Hello, today we're going to be learning about polygons, and specifically, by the end of the day, you should say I can determine and apply formulas for the interior angle sum, and you can do that same thing with the exterior angle sum. All right, first thing we want to look at is by the end of the day, we'll be able to find interior and exterior angles in a regular nonagon. Well, before we do that, we got to figure out what a nonagon is. Well, first, a polygon in general is a figure with a finite number of sides. I have this nice little feature here that gives us polygons. So say if I want 8 sides, I can draw a nice polygon, or 11 sides. There is an undecagon. And these are named by the number of sides they have. For instance, a triangle has 3 sides, and a quadrilateral 4. Pentagon 5, hexagon 6, then we go heptagon, octagon, nonagon, decagon, undecagon, and dodecagon. Now, there's interior and exterior angles in a polygon. The interior ones are the ones on the inside. And the exterior angles are the ones on the outside. So there's interior over here, exterior here, and we need to know those. And here's an exterior. One thing we need to know is the interior angle plus the exterior angle will always equal 180 degrees because they're formed on a straight line. So if we want to find the sum of an interior of an angle of a triangle, those are the ones on the inside, we've known is 180 degrees. If I want to find the sum of the interior angles of a quadrilateral, now that's a little bit different. So what we do is we take any one vertex in the quadrilateral and draw all the diagonals we can. And when we do that in a quadrilateral, that creates 2 triangles. Those 2 triangles each have an interior angle sum of 180 degrees. So in total, they will add up to 360 degrees. Now, if I want to find the interior angles of a hexagon, we do the same thing. We take any vertex, I'll take this one, and we draw as many triangles as we can to each of these vertices. That creates 1, 2, 3, and 4 triangles. And each of those triangles have a sum of 180 degrees. So I just take 180 times 4, and I get 720. All right. Now I want to do the same thing with an octagon. So I take one vertex, and I draw as many triangles as I can. And there's 1, 2, 3, 4, 5, and 6. So there's 6 triangles. Multiply that by 180. And I get a grand total of 1,080. Now, one thing that you should notice is if I have 8 sides, I get 6 triangles. If I have 6 sides, I get 4 triangles. If I have 3 sides, that's only 1 triangle. And 4 sides, that is 2 triangles. And the reason really is that you can draw a line to each vertex to make a triangle, except for the 2 that are right next to you. So there's always 2 less triangles than there are sides in that object. So that helps us when we want to find a formula. Because when we're trying to find a formula, what we do is we take 180 degrees and then multiply it by how many triangles. Now the number of triangles are the number of sides, and then subtract 2 from that. So if I want to use this formula, what I do is I think back here. If something has 22 sides, I'll know that it has 2 less than this triangles. And then I multiply that times 180. So 180 times 20. So I'll just go to my calculator, do 180 times 20, and I'll have 3,600 degrees is the sum of all the angles in a polygon with 22 sides. If this is equiangular, so if all the angles are equal, if we want to find the measure of each of those, I take 3,600 and I divide it by 22, and each angle is 163.63 repeating degrees. Now let's look at a pentagon. A pentagon has, so we'll assume that this is a regular pentagon. And so what we do is we take 180 times 5 minus 2, since it has 5 sides. So 180 times 3, and that is 540. Now since there's 5 sides, we take 540 divided by 5, and that will be 108. So each angle would be 108. Now there is kind of an equation, and we have to know what regular means. So a regular polygon has congruent sides and congruent angles. So if it's a regular polygon and it has congruent sides and congruent angles, what we can use is an equation to find one of them, where, so one interior, this only works if it's a regular polygon, and it's going to be 180 times n minus 2, and then we'll divide it by how many sides, which is n. Alrighty, let's keep rolling. Let's talk about the exterior angles. We know that the interior angles are all 108. So if the interior angles are all 108, the exteriors are all 72. And so if all the exteriors are 72, the sum of them is 72 times 5, which equals 360 degrees. So the sum of the exterior angles in a pentagon is 360. So let's look at this triangle. If this is 70, this angle is 110, this is 100, because these should all add up to 180, and this is 150. If I add these all up, that would be sum of exterior, again, equals 360 degrees. And you say, huh, that's odd. Well, what about for different polygons? Well, the sum of the exterior angles in a polygon is always 360 degrees. And the reason is, if I made the polygon really small and just extended, or extended these out, these exterior angles will always add up to a full circle, whether it's a small one or whether it has 5 exterior angles, or whether it has 1, 2, 3, 4, 5, 6, 7, 8 exterior angles. They'll all make a circle, which will add up to 360. And that gives us a couple more formulas. If I take 360 degrees, divide it by the number of the measure of one exterior angle, I would find out how many sides that shape has. Similarly, if I take 360 and divide by how many sides, for instance, this one has 8 sides, I would find out the measure of one exterior angle. Now again, both of these formulas only work for regular polygons. That means equal sides and equal angles. All right, let's keep rolling. If each exterior in a regular polygon is 14.4, find the number of sides. Well, we know 360 divided by exterior angle is going to equal the number of sides. So 360 divided by 14.4 is going to give us 25. So there are 25, oops, that's not the button I wanted to push, 25 sides. Let's try this next one. The interior angle of a regular polygon, so it's regular, we can use our regular formulas, is 162. Find the number of sides of that polygon. Well, we know 180 minus 162 is going to give us 18. So that's the exterior angle. So if I take 360 divided by my exterior angle, which is 18, I should get 20. And so that means there's 20 sides. All right, So now our success criteria, we're through the lesson. We just need to figure out how to find the interior angle and an exterior angle of a regular nonagon. And the easiest thing to do, if it's regular, find the exterior angle, because 360 divided by the number of sides will give you your exterior. 360 divided by 9 is 40. So if your exterior angle is 40, I just have to subtract that from 180, which is 140, to get my interior. Hopefully you feel like you're doing pretty good on this lesson. Take a second and rate yourself on an understanding level of 0 to 5 at how well you did on those. And once you did that, you can start up with the homework.